Here we go. I am trying some new software, so please be patient with me. What we're going to talk about today is combination lenses, which is when you have two lenses, and it's a little bit complicated. So I'm going to try and go slowly, and let's see if we can figure this out. The idea is that you have, I'm going to just say lens number one and lens number two. And our object is usually going to go right here. And the deal is that lens number one could be converging or diverging. Lens number two could be converging or diverging, and you're ultimately going to get an image. And it really depends on a few things. One, what kind of lens it is, and also the relationship between the object and the lenses. Now, here's the really wild part. You got to think about it this way. The light is going to go from the object through lens number one, and it's going to create an image. We will call that image number one. So this is object number one. We'll create image number one. Image number one becomes the object for lens number two. Crazy, right? So image number one becomes object number two, and then we just look at how it interacts with lens number two, and we look at the final image that is formed. I will give you a website that you can play around with and check this out. It's the Optics Bench. If you don't believe me, it's pretty cool. We're not going to do ray diagrams with it because it's way too complicated, but Optics Bench does that for us. Okay, so let's give it a shot. First of all, my recommendation is draw the picture always. You don't actually have to draw the lenses in, just call them lens one, lens two. You don't have to draw them in as converging or diverging, whatever. But my recommendation is that you write down what F1 is, you write down what F2 is, and you put in as much information as possible. Our assumptions are going to be that object number one is always upright and it's always to the left of lens number one. And so that means that DO1 is always going to be positive. Oops, sorry, I already did that. Okay, so let's just play pretend. Let's pretend that our first case is if DI1 is positive. So that means it's going to end up over here. We're very rarely going to end up with an image all the way over here. So let's just pretend that image number one is over here. Now, one of the facts you're going to be given is the separation between the two lenses. And I'm going to call that X. Okay, so here's the deal. This is going to be DO1, and this is going to be DI1. Remember, because that's the image number one, and the DI is always measured from lens number one. Now, the very exciting part is this is also object number two. And so that means that this would be DO2, and then based on where the final image is, that's going to be DI2. Now, I prefer that you draw the picture and use your common sense. I'm going to give you an equation. Actually, you know what? I'm not going to give you the equation. We'll talk about it in class. So this is my preference, is that you draw it out and you figure out what DO1 is, DI1 is, DO2 is. And obviously, you're going to do some calculations to figure out DI2. Okay, so an example of this will be from the problem sheet that I gave you, called Practice Problems for Lenses in Combination. Let's start to work our way through number one, because number one is exactly this story. Okay, we won't get into, we're just going to do right now part A, because that's all you're prepared for. But here's the deal. Okay, so converging lens lies to the left of another converging lens. So they're saying this one is 10 centimeters, and F2 is going to be 5 centimeters, and they're both converging. And in this case, the object is 15 centimeters to the left, so we're going to say it's right here. And the two lenses are separated by a distance of 45 centimeters. So with that information, you actually have enough to figure out where the image is going to be. Ready? So we're going to write down our information like this for lens one and lens two. So lens one, we know DO1 is 15 centimeters. F1 is 10 centimeters. We know that F2 is 5 centimeters. We don't know yet what DO2 is. We will in a second. So let's start out by looking for DI1. And you just use the lens mirror equation, not very complicated. Okay, and so 1 over 10 equals 1 over 15 plus 1 over di. Go ahead and put that into your calculator. You might want to pause the video, and you should get di1 equals 30 centimeters. Okay, so I'm going to go back to the drawing and put that number in. That means that this number here, let's make it blue, what did I just say? 30 centimeters. Well, you know the whole thing is 45, so using your common sense, I know that you know this must be 15 centimeters, right? So we're going to fill that in. So that's going to be 15 centimeters. And now we can play the same game to figure out where the di2 is. So 1 over f equals 1 over do plus 1 over di. 1 over 5 equals 1 over 15 plus 1 over di. And what that gives us is di2. And I got that di2 is 7.5 centimeters. So the way we would write that then is that the image is 7.5 centimeters to the right of lens number 2. How do I know that it's to the right? Well, because it's positive. So I know that it's going to end up actually over here. This is going to be your final image. And this is going to be 7.5 centimeters. Why did I draw it upright? Well, remember this one over here, image number 1 was real, so I knew it had to be inverted. And if that one is inverted, this is also a real image. It's also going to be inverted, but it's inverted twice, which means it's upright. Isn't that crazy? Okay, so that's for that kind. We're going to come back to problem number 1, but let's just do another example. What if? Okay, so what if? So. Same story. What if the first image is not real? What if it does not end up in here between these two lenses? Well, that must mean it's virtual, right? So it could be, if this was a converging lens, it could be that DO is less than F, and that would make for a virtual image. Or it could mean that this is a diverging lens. So I'm going to just say if DI1 is negative. And we're going to do this using number 2. Okay? Because I just think it's a little bit easier with an example. So a diverging lens lies 50 centimeters to the left. Here we go. DO1 is 50 centimeters. Wrong. X is 50 centimeters, sorry. This is a diverging lens, and this means F1 is negative 20 centimeters, and F2 they give us is what? 15 centimeters. And this is not 10, but in fact this is 10. Sorry. Okay, so since it's a diverging lens, we know that the image is going to end up on the same side of the lens as the object. Let's do the math to prove it to ourselves. So again, this is lens number 1, and DO1 is 10 centimeters, and F1 is negative 20 centimeters. And so let's find DI1. So 1 over F equals 1 over DO plus 1 over DI. And yes, you need to write that every time. 1 over negative 20 equals 1 over 10 plus 1 over di. So that's going to tell me di1. And I got that di1 equals negative 6.67 centimeters, which makes total sense because that's guaranteeing that I've got, I'm going to put it in red, I've got an image and it is right here. That is image number 1, which is the same as object number 2. Okay. Hopefully you're with me. If not, pause, maybe review, rewind, think about it. Okay, so now this is object number 2. So guess what I'll do in orange, guess what my new DO is? It's this distance right here. This is DO2 because it is with regards to lens number 2. So let's put in our lens number 2 information. I just said that DO2 is, I didn't say actually, let's say, it's going to be 6.67 because that's what that number is. So 6.67 plus 50, and that's going to give us 56.67 centimeters. Okay, hopefully that makes sense. We take the absolute value because we're really looking for this distance. The negative tells you it's on this side of lens number 1, but we're looking for this whole distance right here in orange. Okay, F2 is, what did we say it was? 15, is that right? 15 centimeters, yep. And I'm looking for DI2. Once again, 1 over F equals 1 over DO plus 1 over DI. And you plug it in, 1 over 15 equals 1 over 56.67 plus 1 over DI. That's going to give us a DI2. And I got the DI2 is 20.4 centimeters, which puts it over here. This is image number 2. How did I know to flip it? Because I know that it is a real image. How did I know that? Because because DI2 is positive. Okay? So this is a real image and it got inverted, but it got inverted from its orientation of its object. Phew. Okay. So there are a lot of different configurations. I could have had that these both were converging, but maybe the object was really close to the lens, in which case you get sort of a similar story. I could get that this one was diverging. So there's a whole bunch of different situations. I gave you 5 for practice, so you should check them out. But let's talk about some other equations and some trends, and that should keep you out of trouble for a little while. Okay. Here's the deal. M total equals M1 times M2. What that means is that's negative DI DO of lens 1 times negative DI over DO of lens 2. Well, those two negatives go away, so what you always get is DI1 over DO1 times DI2 over DO2. Okay, the negative sign plug goes away, so you just literally plug in the numbers that you have. So let's go back. We're going to do this a little bit funny. We're going to do 1B, and then we'll do 2B. All right, because that's what those are asking, is to find the total magnification, which is the same thing as the overall magnification. So for number 1, go back to your data for number 1, M total was, again, DI over DO of lens 1, DI DO of lens 2. So I got 30 over 15 times 7.5 over 15, and that ends up being 1. That is not always going to be the case. And then if you do it again for 2B, because that's asking the same thing, and again, go back to our numbers. So M total will be DI over DO1 times DI over DO2 equals negative 6.67. Where did the negative come from? I just told you to get rid of them because that's the actual DI for lens number 1 is negative 6.67 over DO multiplied by 20.4 over 56.67. And I got negative 0.24. You should always check my math. Okay, so those are some examples of how to use that M total equation. Let's do a few trends. Where did my notes go? Here they are. Okay, and the trends are pretty straightforward. If the absolute value of M total is bigger than 1, I'm hoping you get that that means that image number 2 is bigger than object number 1. So now I'm going to do the reverse. If the absolute value of M total is less than 1, image number 2 is less than object number 1. We're talking about heights, right? If M total, oops, not absolute value, just regular old M total is positive, then the image is upright. If M total is negative, then the image is inverted. And again, we're going to always assume that our object starts out upright. That's important. And I need to give you one more equation. I told you what M total was. That is also equal to HI2 over HO1. All right, hopefully that makes sense because it's the overall magnification. We're looking at how this second image corresponds to the first object. And then one more set of rules, and then we'll go back to the practices. If DI2 is positive, then it's a real image. If DI2 is negative, then it is a virtual image. Okay? All right, now let's go back and really quickly, I'm going to give you the answers for number 2 and number 1, C through E. So for number 1, C, I got it was real. Why? You tell me. We can discuss in class. Number 2, I got that it was inverted. Sorry, D, I got that it was inverted. And E, I got that it was, oh shoot, doing the wrong problem. Undo. Sorry. Lost track of my notes. Okay, 1C is still real. 1D is upright. It actually flipped twice. And the idea, because they gave you the actual height, is HI2 is 2 centimeters. Remember that magnification was 1. 2C is real. 2D is inverted. And 2E is smaller. All right, I want you to tell me why. Not literally, you're not going to hand it in or anything, but be able to tell me why in class, because please, I really hope I see you on Wednesday. This is getting a little crazy. Okay, I think that's it. End scene. And I will, if you want to know the answers to the other practice questions, let me know. I will do them out. Okay, that's it.